2022, Paper 2, Question 14. We have to find the side BC, and we have this complicated looking diagram, and we're told about the angles of elevation. If you want to pause the video and have a go at it yourself, but otherwise I'm going to continue. This one is a challenging question. We want to find BC, but you've got a right angled triangle, and you've then got the second one over here, which is not right angled, and they're essentially joined together to make one big triangle, and the big one happens to be right angled. But the easiest way to do this one is, first of all, to split it into two triangles. Call this 1 and 2. So having a look at triangle 2, is this one, and we'll use the letters A, C and D. What's going to happen in this one is that if we can find the length AC, then we can use right angled trigonometry to then find BC. The first thing we want to do is find AC. So what do we know? We know the angle is 12. And we want to find AC. So we know one pair of information, and we have, this is 15. And in order to find the angles, what we want to do is, well, 180 take away 28 is 152. Is the angle C. It's just angles around a straight line have to equal 180. So that is 152. And the angle in here would be this angle, that would be 28. And this angle is, well, that's 164. That's then going to be 16 degrees. And we want to find AC. So we're going to look at the formulas here, and we're finding a side, not an angle, so we don't want to use this one, because this version of the cosine rule is if you know three sides and you want to find an angle, but that doesn't apply to us. And this one, you need to know two sides in order to be able to substitute the two sides in, but we only know one and want to find the second, so we can't use the cosine rule. But we can use the sine rule, because we have this and we want to know this. We know this and we know this. So we have a pair of sides and angles, and we know both of them, and we have this second pair of sides and angles. We know an angle and want to find a side, so we can substitute that into the sine rule. Now, in non-right angled trigonometry, the convention is small letters are opposite the angles of the capital letter. So capital A angle is opposite side small a, small c, the side is opposite capital C angle, and the same with this one. So we have angles A and side A, so A over sine of A and D over sine of D, capital D. Watch out with your small letters and your capitals. Now small a is 15. Sine of a is the sine of 16. Small d is what we want to find out. And the sine of d is the sine of 12. Now, we've got the sine of 12 is on the bottom of the fraction. So if you multiply both sides by the sine of 12, you get d equals 15 sine of 12, because the opposite operations. Divide sine of 12, then multiply, then we swap the equation round. It gives us 15 multiplied by the sine of 12 divided by the sine of 16. And the answer we get, if we plug that in, make sure to use degrees and not radians. Would be 11.31441. 31441. And the units are meters. Do not round too early, because that will end up giving you a wrong answer, or it might end up giving you a wrong answer at the end. So you only round once you've got to the end of the question. So calculate BC is that, and we know that is AC. Now you know SOHCAHTOA, where you have sine equals opposite. So sine equals opposite over hypotenuse. That's not very neat. So sine equals opposite O over hypotenuse H. Cosine is A adjacent over H hypotenuse, and tan is opposite O over adjacent A. Now we want to find BC, and for right-angled trigonometry, you don't really want to use the convention of small letters and capitals. So we'll switch D back to AC. You can, using AC or small letter d on its own, effectively mean the same thing in this case. So we'll go back to using AC. Now BC is adjacent to the angle, and AC is the hypotenuse. It's opposite the right angle. So for right-angled trigonometry, we're going to retire the use of that lettering convention, and we've got the adjacent, we've got the hypotenuse, we have this. So the cosine of the angle is 28, is the the adjacent is BC. The hypotenuse is 11.31441. Again, this is being the BC is divide 11.31. Sorry, the it's BC divided by 11.31441. So you want to multiply by 11.31441 because the division and the multiplication will cancel each other out. Took me ages to get that out. Sometimes I have those moments that I get my words mixed up. So let's multiply both by 11.31441 multiplied by the cosine of 28. And plug that into the calculator. You get 9.99004 meters. And we're given no rules about rounding in the question. I think rounding to 3 significant figures is a good idea. We've got too many, I would say, in this version. So to 3 significant figures, BC equals 9.99 meters. And that's us done. That took quite a lot, and this definitely is a difficult question. So if you're finding this one hard, I would keep practicing these types of questions, because sometimes you can get these right-angled and non-right-angled trig in the same question, but I wouldn't worry. You can easily still get an A in the exam if you're finding this one hard, because this is aimed at the top students. And let's have a look at the SQA and how they would mark this question. The first mark would be for substituting into the equation. The second mark would be for rearranging. The third mark would be for finding AC. The fourth mark would be for this. And the fifth mark would be for the answer. Having a look at the common mistakes or responses that pupils gave. Number one is no working would get no marks, because the examiner or the marker needs to see that you're able to apply the sine and cosine rule, and that you know when to use the sine and the cosine rule. The second one is they would accept an answer of 10 if you showed the working. I think that's quite generous of the SQA, but you had to show all of the working, because 10 on its own does look like a bit of an easy guess. And a commonly observed response was using rad or grad, with rad being radians, but you don't use that until you get to higher, so you only lose 1 mark in each paper. So if you use radians in the whole exam and you keep making mistakes because of your use of radians, you should only lose 1 mark There are some exceptions to this though, that if you get negative values of sides, then you would lose marks again. But generally, with a few exceptions, you should only lose 1 mark, and those exceptions are given here because if you get the negatives, then you can't get follow through marks. Just make sure the calculator is on the right mode. So I hope you found this video useful, and yeah, best of luck with the studying. Thank you for watching.